Today we are going to see how to control an LED with the help of a switch using Arduino Uno board. So this is a simulation model of the Arduino Uno board, and in Arduino Uno board you already know that in pin number 13 there is an onboard LED connected. Right? I am representing that onboard LED by using this LED D1, and a resistor is connected in series to that. Then here I need to connect a push button switch. With the help of the push button switch, I am going to switch on the LED as well as switch off the LED. So I am connecting the push button switch to pin number 2 of Arduino Uno, and one end of the push button switch I am connecting to VCC, and the other end I am also connecting a 1K resistor or a 10K resistor, or basically high value resistor. I am connecting it to ground. So what is the purpose of using this high value resistor? When I am pressing this switch, what will happen? This VCC or the power will be connected to pin number 2. But when I am releasing this switch, what will happen? This pin number 2 will be in floating state, or it is known as high impedance state. So what do you mean by that high impedance state? If you are reading the data available in this pin, the processor will not be able to identify whether it is 0 or 1, because sometimes it may be represented as 0 and at some other point of time it will be read as 1. Right? So when I am pressing the switch, you can see that VCC is connected to pin number 2. So if you are reading from this pin, you will get the data as 1. But when I am releasing the switch, pin number 2 will be in high impedance state. So I don't know whether I am getting 0 or 1. Sometimes it will be read as 0. Sometimes it will be read as 1. But when I am writing a program, I cannot write like this. I can write only in such a way that I can check for either 1 or either 0 in the program. So when I am pressing the switch, VCC will be going in, so I can check for 1 because I am getting 1. But when I am releasing, somehow I need to get 0 in pin number 2. Then only I can write a program accordingly. So when I am pressing the switch, I will be getting 1, LED can be switched on. When I am releasing the switch, I should get 0. So I can check for 0. If the value is 0, I can switch off the LED. So how is it possible? For that, I am connecting an external resistance to pin number 2, and the other end of the resistance it is connected to ground. So this is known as pull down resistance. Pull down resistor. That means it is pulling down the data present in this pin number 2 to ground. It is pulling down the data present in this pin number 2 to ground. So whenever the switch is off or it is released, pin number 2 will be connected to ground through this resistor. So this is how we are solving the problem of that floating state or high impedance state. That is the purpose of using this pull down resistor. So you may ask that when you are pressing this push button switch, whether the VCC or ground will be read from this pin. Since the VCC is going through this path, which is the least resistance path when compared to the other path where there is a high value resistance. So here the resistance will be more. In this path the resistance will be less. So when you are pressing the switch, VCC will be going through this pin, and when you are reading from the pin, you will be getting it as 1. So now what you should do? I have made the hardware connection. What program should I write? When I am pressing the switch, I should check for the data or read the data from pin number 2. If the read data is 1, 1 means it is nothing but the VCC. If the read data is 1, I need to make the LED connected to pin number 13 as on. And when I am releasing the switch, what will I get? When I am reading the data, I will be getting the data as 0 in pin number 2. So if the read data from the same switch, that means if you are reading pin number 2, if I am getting 0 as the data, I need to make the LED off. So this process I am going to implement using TinkerCad IDE. So now I have logged on to tinkercad.com. So you can see all the circuits which I have previously designed. Now you can click on create a new circuit. Then first of all you can drag and drop the Arduino Uno from this basic components list. You can scroll this and you will get the Arduino Uno revision 3. Then as the next step, I need to connect the switch as well as resistance to the corresponding pins. So again scroll up, you can see the push button switch, you can keep it here. Then the first end of the switch I am going to connect to pin number 2. This is pin number 2. So I am going to connect the first pin of the switch to pin number 2. This is pin number 2. And the opposite side of that pin I am going to connect to through a resistance to the ground. So I need to take a resistance. So scroll up, take the resistance, keep it here. So I am going to connect the opposite end of terminal 1, that is known as terminal 1A. I am going to connect to the resistance, and the other end of the resistance I am going to connect it to ground. So this is a ground. Now I am going to connect this pin, that is pin number 2A, to VCC or 5 volt. VCC means 5 volt. So let us take this is a circuit connection. So how it is working, how the pins of the push button is working. Normally in the push button switch, this 1A, see here when you are keeping on the pin, you can see this is 1A, this is 1B. In a push button switch, normally 1A and 1B will be connected in series by default. That means these two pins will be in contact by default. So what I have done, I have connected pin number 2 to 1B. Pin number 2 of Arduino I am connecting it to 1B, and through a resistance I am connecting pin number 1A to ground. So what I am doing here, I am connecting pin number 2 through a resistance, high value resistance, to ground. So I have connected the pull-up resistance through the switch to ground of Arduino. Then what is the speciality of pin number 2A? What is the speciality of pin 2A? Why I have connected this pin 2A to VCC? Because in a push button switch, when I am pressing this switch, pin number 2A and pin number 1B will be in contact. 2A and 1B will be in contact. That means the diagonal pins will be in contact when you are pressing this switch. Similarly, pin number 1A and 2B will be in contact when you are pressing the switch. So both the diagonal pins will be in contact when you are pressing the switch. When you are releasing the switch, both the pins which are in same line will be in contact. That is 1B and 1A will be in contact when you are releasing the switch. And the diagonal pins, that is pin number 2A and 1B, that is the diagonal pins 2A and 1B will be in contact when you are pressing the switch. Similarly, when you are pressing the switch, the other diagonal pins 1A and 2B will be in contact when you are pressing the switch. So in my connection, what I mean, when I am pressing the switch, I should get 5 volt connected to pin number 2. That is why I am connecting 5 volt to 2A, and when I am pressing the switch, what will happen? This 5 volt will be in contact from 2A to 1B, and the same 5 volt will be available here when I am pressing the switch, that will be sent to 2. So when I am pressing the switch, VCC will be connected to pin number 2. So if I am reading from pin number 2, you will get it as 1 or digital 1. And when you are releasing the switch, the same pin number 2 will be connected through this resistance to ground. So when I am releasing the switch and I am reading the data from pin number 2, I will get the data as digital 0. So that is how we have implemented the same circuit I have shown in the previous PPT using this TinkerCad. So circuit diagram I have implemented. What is the next step? I need to write the code for this. So for that I am clicking on this code button. So by default you will be getting an LED blinking code here. For time being I am deleting that code. How will I delete the code? Click on this block, drag and drop it to this recycle bin button. Click on the block, drag and drop it to the recycle bin. Now you can see the recycle bin is open. Now you can release the button. So it will be deleted. So I am going to write the block programming for this circuit. So what should I do? My first step is I need to read pin number 2. So for that, click on this input block set. Then you can see read digital pin 0 block is there. Drag and drop it here. And in my case, which digital pin I need to read? I need to read the data from D2 or digital pin 2. So you can click on this drop down and select digital pin 2. So I am reading from digital pin 2. Then what should I do? I need to check whether this digital pin 2 is equal to 1 or digital 1. So how will I perform this equality check? For that you need to click on the math block set. So click on math block set. Take any one of this. You need to take this or this. For time being I am taking this block set with the arrowheads on both the sides. So I am dragging and dropping it here. Then what should I do? By default it is written as 1 less than or 1. Instead of checking 1 less than or 1, I need to check the data read from digital pin 2 whether it is equal to 1. So for that what should I do? Drag and drop this block inside the math block set. So now what I am doing is I am reading the digital pin 2. I need to check whether it is equal to 1. So click on this logical drop down, then select equal to. So what I am doing is I am checking whether digital pin 2 is equal to 1. Then what should I do? If digital pin 2 is equal to 1, what should I do? I need to make the onboard LED on. That means I need to set onboard LED to high. So before that what should I do? I need to check whether this is equal, right? So if digital pin 2 is equal to 1, then only I need to make the LED on. So I need to have a if then else statement. So how will I do that? You need to click on the control block. So here you can see all the control blocks. You need to select if then else block. So I am dragging and dropping the if then else block. So what is my condition? If what is my condition? This is my condition. So drag and drop it inside. So if digital pin 2 equal to 1, if digital pin 2 is equal to 1, what should I do? Then I need to set the onboard LED high. So how will I make this onboard LED high? In the LED blinking program we have seen that. So for that click on the output block set. Take this set built-in LED to high. Drag and drop it inside. So when digital pin 2 is equal to 1, then onboard LED or built-in LED will be made as high or it will be on. Else what should I do? I need to drag and drop the same block and make this high to low. So what does it mean? If digital pin 2 value what I have read is equal to 1 or digital 1, the onboard LED or built-in LED will be on or it will be set to high. And if the digital value what you are reading from here is not equal to 1, that means it is equal to 0. When the value is equal to 0, the built-in LED will be low. Right? So this is how you are writing an LED switch control program using TinkerCad. So here I am using visual programming or block programming instead of writing the actual code. Now what should I do? You can click on this code button again so that it will vanish. Next step is I need to start the simulation. How will I start the simulation? Click on the start simulation. So it will be showing initializing. So now the simulation has started. So here you can see that the LED written with L, that is your inbuilt LED or onboard LED connected to pin number 13 internally. So how will I do that? How will I make this LED on? You can press this switch. When I am pressing the switch, when I am keep on pressing the switch, you can see that the LED will be on. When I am pressing the switch, the LED is on. When I am releasing the switch, LED is off. So when I am pressing, you can see that the LED is on in orange color. When I am releasing, the LED is on and LED is off. So this LED you need to see. If you want to zoom it, you can zoom it. You can scroll the mouse button little bit. If I am scrolling the mouse button little bit, you can zoom it, right? So that it will be more visible. If you want to get the whole workspace, you can hide this components. You can click on this arrow, hide components panel, so you can see it more visibly. Again, you can scroll the mouse button up, now it is more visible. So this is a LED, inbuilt LED. When I am pressing the switch, you can see that the LED is on with the orange color. When I am releasing the LED, LED is off. So this is how you are performing an LED switch program using TinkerCAD simulator.